Good morning. In this presentation, we'll see NoSQL. RDBMS characteristics. RDBMS is Relational Database Management System, so which is a traditional database management system that we are using now. So the data are stored in the form of tables, which is basically in as rows and columns. And relationship between data is being maintained, and we use structured query language where we have data manipulation language, data definition language, transaction control language, etc. And there is abstraction from physical layer. Applications specify what is required and not how to bring the data. Physical layer can change without modifying applications. So we create indexes to support queries, and there is in-memory databases. So in RDBMS, we follow ACID properties. So any transaction should follow ACID properties. So ACID is atomicity, consistency, isolation, and durability. So what is atomicity? All of the work in a transaction completes or none of it completes. So either a transaction is fully completed or it is not at all completed. So there is no partial completion. Then we have consistency. A transaction transforms the database from one consistent state to another consistent state, and consistency is defined in terms of constraints. So when we try to access the data, we should not get two different data for the same query. Then we have isolation. The results of any changes made during a transaction are not visible until the transaction is committed. So a transaction that is being performed will not affect other transactions, and other transactions or property changes will not affect the current transaction. Durability, in case of failure, still the transactions and the data is consistent and it is committed. That is being ensured by the durability. So in RDBMS, we follow ACID properties. So what is NoSQL? NoSQL stands for No Relational Database or No RDBMS, and not only SQL is a general term that is being followed for NoSQL. So NoSQL is a term for all the databases and data stores that don't follow RDBMS basically. It is a class of products, a collection of several concepts about data storage and manipulation, often related to large data sets. That's why we are discussing this in big data. So what is NoSQL? So official definition given by NoSQLdatabase.org is that it is non-relational, it is distributed, it is open source, and it is horizontally scalable. So the basic intention behind NoSQL database is web should be scalable, and the other characteristics are also schema free. It could be replicable, and we have simple APIs to access the database, and it can handle large volume of database, and it doesn't follow ACID properties where we need to define certain properties that could be followed by NoSQL. So non-relational DBMS are not new, but NoSQL represents a new incarnation. So specifically, as we discussed, it is for large volume of data, and it is going to support distributed and parallel computing. So it was initially developed by Google in 2003. There was a research paper, and it is enhanced, and architecture, a new distributed architecture is found by Apache, which is named as Hadoop, and Amazon also gave a database which is based on NoSQL database, which is referred as DynamoDB, and various other companies have adopted this. And what is DynamoDB and Bigtable? It is specifically NoSQL databases that are being developed and used by Google and Amazon. DynamoDB is based on distributed key value, and it maintains consistency. So we will be following CAP theorem instead of ACID properties here. So we'll discuss what is CAP theorem in the forthcoming slides. NoSQL comes from internet Thus, it is often related to the big data concept. So we know what is big data is. Big data is large volume of data. So the source of the big data is basically internet. So internet often creates large volume of data. So we need to store those data and process those data to get insights. So we discuss in NoSQL along with big data. So how much bigger big data? At least few terabytes, and we need multiple storage units. We will not store it in a single system. So what are the challenges that we have? So efficiently storing and accessing large volume of data is difficult. And when it comes to taking a backup, so we already have a large volume of data. So to replicate it or to have a backup of the large volume of data, so we need that much hardware capacity or storage capacity to take a backup also. And manipulating this also requires high computing capability, so we need to do it in parallel. Managing continuously evolving schema and metadata is also difficult because internet creates mostly semi-structured and unstructured data. So as we know, the social media has given power to each and every individual to generate the data. So the data is getting generated very fast and in large volume. And the technology has also moved from a standalone system or in just a client server model. We move to cloud based solutions, and the programming languages also has also evolved, like Python, Ruby, which gives dynamically typed data, so frequent schema changes is also done. And we have open source community. Why are RDBMS not suitable for big data? So we know RDBMS is structured. So the here the data that are mostly getting generated is from internet, and internet generates mostly semi-structured or unstructured data. So RDBMS typically follows structured data, and it is the data is dense and interrelated. Here it is massive and sparse, and also semi-structured or unstructured when it comes to big data. NoSQL specific characteristics is that, so large data volumes, as we know, scalable replication and distribution, which means we can take copies of the data and store it in different machines, and possibly it is possible to collect all those data whenever it is required, which means we can make a query with distributed data. And queries need to run answers quickly. Mostly queries will have few updates, and the updates are asynchronous in nature, and it is schemaless, and we are not going to follow ACID properties, and we'll have cap theorem. And of course, NoSQL, we have open source development. So these are the types of NoSQL databases, where sorted, ordered column store, where which is basically column oriented databases. Then we have document databases. Then we have key value databases. Then we have graph databases. What is document database? In document databases, of course, we follow loosely structured key value pairs, and the document itself is seen as a single database. It encapsulates and encodes data in some standard formats or encodings, are addressed in the database via a unique key. Documents are treated as a whole, and we do not split the document, so it will have consistent name value pairs. So notable document databases are MongoDB and CouchDB. So the central concept in the notion of a document database is like we have a single row in RDBMS. A document comes in a standard format like JSON, JavaScript object notation, or a binary object notation also possible. Documents are addressed in the database via unique key that represents the document. Database offers an API or query language that can be used to retrieve the data present in the document. Documents are schema free, so we will not have structure, or we follow semi structure, not like RDBMS. We strictly follow the schema. So this is an example. So this is how JSON look like. So here we can see the key value pair. Here ID, type, author, title, date, body are all key, and article and whatever is present in double quotes after the colon is values. So we can see that we have two data, and both the data we have different fields. For example, here we don't have title, ISBN. Here you can see that we don't have date and body. So this is a record and this is another record. So both don't have similar fields or similar keys. So we can see that it is semi-structured, and each and every record set can have different key and value pair. So how key values are stored? So we store it in a schema-less way. Store data as maps. Hash maps is basically used, and it provides a very efficient average running time algorithm for accessing that data. So hash map is the data structure that we use. So what are the databases that we that uses key value stores? Couchbase, Redis, Amazon Dynamo, Apache Cassandra, etc. Next is sorted, ordered, column oriented stores. So where we store the data based on columns. So data are stored in a column oriented way. So they are being divided based on the columns. Columns are grouped in column families. Data isn't stored as a single table, but stored by column families. So unit of data is a set of key value pairs. Here the key is the group of columns is named with a single key, which can be accessed or which can be distributed also based on the key that is assigned. So this is what is being used in big table of Google, and HBase is a column oriented database. Then we have graph databases. Everything is stored as an edge or a node or an attribute. Each node and edge can have any number of attributes. Both the nodes and edges can be labeled. Labels can be used to narrow searches. Typical graph structure where we have nodes and edges. Nodes and edges can have attributes, or the way the data flows around the nodes. So it is mentioned, and it is a directed graph. Graph databases are mostly used in social networks. So dealing with big data and scalability. Scalability is primarily whenever a large volume of data comes, as we need to increase the memory capacity or storage capacity, is it possible to do that? So what are the issues with scaling when the data is just too big? So in RDBMS, it is not designed in a distributed fashion. So we have a single system. So with the capacity limited to the single system, the maximum data can be stored. So if we need to store more data, then we need to move to the distributed system. So NoSQL supports this distributed system. For example, if we consider column oriented databases, so we divide the database into different tables based on the column families. So each column family can be stored in different systems. So horizontal scaling is very well possible. So we have different approaches towards it. One among them is master slave, and the other one is sharding, which is partitioning. So what is master slave? So in NoSQL we have write once and read many methodology. So that is supported by master slave. All writes are returned to the master. All reads performed against the replicated data slave databases. Critical reads may be incorrect because it will take time if we write to the master, and periodically it is getting updated to the slaves. Large data sets can pose problems as master needs to duplicate data too. So this we have in master slave. And when it comes to sharding, any DB which is database distributed across multiple machines need to know in what machine a piece of data is stored or must be stored. So we can divide the data and store it across multiple devices, but we need to maintain where the data is getting stored. A sharding system makes this decision for each row using its key. No SQL, no ACID properties. So we are going to follow CAP theorem. So no SQL does not give importance to ACID properties. So we are not going to maintain all four properties. So since it is a distributed parallel system, we need to have a separate properties for NoSQL databases. So instead of ACID properties, we start with base. Base is basically available, soft state, eventually consistent. The characteristics is weak consistency, availability first, best effort, approximate answers, aggressive, simpler, and faster. So we will be following CAP theorem in NoSQL databases. A congruent and logical way for assessing the problems involved in assuring ACID-like guarantees in distributed systems is provided by the CAP theorem. At most, two of the following three can be maximized at one time. So we prefer or we trade off with the two properties: consistency, availability, partition tolerance. So we trade off with two properties. Either we go for consistency, availability, or consistency, partition tolerance. In that fashion, we prefer to take two properties. Okay. At most, two properties and three can be addressed. Availability is compromised, but consistency and partition tolerance are preferred over it. So availability, when we compromise on availability, so consistency and partition tolerance can be given. The system has little or no partition tolerance, then consistency and availability are preferred. Consistency is compromised when systems are always available and can work when parts of it are partitioned. Okay, so availability is, so whenever I try to access the data, I should be able to access the data. Consistency is when I access the data, even it comes from multiple sources, I should get the same data. Partition tolerance is I'm going to store the data in distributed fashion, so whatever transactions I do, it should be consistent, and it should tolerate with the partitions also. So consistency, availability is not binary decision. Okay, so any availability and partition tolerance systems lack consistency, whereas we need to make a trade-off. We compromise with any one of the theorem. So this suggests both AP and CP systems can offer a degree of consistency and availability as well as partition tolerance. Okay. So the performance, there is no perfect NoSQL database. So everything has advantages and disadvantages. So based on the requirement, we need to choose this NoSQL database. So NoSQL is a set of concepts, ideas, technologies, and software that can deal with big data, semi-structured and unstructured data, where high horizontal scalability is available, massive parallel processing is possible. Different applications, goals, targets, approaches, different NoSQL solutions. So one single NoSQL database is not solution to all the problems. Where would I use it? So any particular application requires different NoSQL databases. So you can use for log analysis, it would be different. For social networking, it would be different. For example, for social networking, you may prefer graph database. For log analysis, you may prefer a document database. So for different applications, the data structure, the structure of the database is also going to change, and it should have NoSQL database capability. Like it could be stored in distributed manner, and it could be processed in parallel. Thank you.